Hello, friends. Welcome to another day of the AI Developer course where we are writing code 10 to 15 minutes every day to learn AI via hands-on coding experience. Well, here we are at the last milestone of Module 1. In Module 1, we learned about LLM basics, prompting techniques, and context engineering. Today, we will not do a micro build task. Today, we will do a deep dive project using everything we have learned in the past few days. Let's have a look at the task. We want to build a chat with video tool. So a tool that is able to chat with a YouTube video that we provide in natural language. Bonus assignment is how would we judge the quality of our AI? And if we had a better model in the market, how would we upgrade it? So let's have a look at the task. All right, let's get started. As usual, please pause the video here and try to do your own research and try to write this project yourself. It's going to be a lot of fun. Once you're done, you can come back here and look at the solution. All right, let's get to it. We want to chat with a YouTube video. So the tool will accept a YouTube link, and we want to use our LLM to be able to chat to the video. Now, of course, our LLMs are not very good at video processing right now, so the easiest path to get to it is to convert the video to text and then chat to the text, which the LLMs are surprisingly great at. So that's what we're going to do. Let's have a look at the structure of this project or the tool. The tool will accept a YouTube URL. So I've got two great YouTube URLs for here. This is this video by Arpit Bayani on DynamoDB, goes into the paper to get details. And the second one is from Andre Karpathy on building a GPT from the scratch. Both amazing videos if you have not watched them already. All right, so the tool asks us for a YouTube link, fetches the ID out of it. We're using a tool, open source tool called YouTube Transcript API here, and it's using the video ID to generate a transcript file. Once we have the text, we can now use this to ask questions to the LLM. Now, this transcript is really, really large, so you'll start using the concepts that you have already gone through. Context caching, because this will be tens of thousands of tokens otherwise if you're just using the entire transcript in every single API call. You probably also might want to use structured output so that the LLM is responding in a certain format. Um, and yeah, we'll use some other concept. Let's have a look at it. So we are going to use Gemini for this particular example. So we have, and we're going to use pydantic for our models. So we have created our answer model, which is, so the way I want this tool to work is you ask a question, it answers you, and it also suggests you follow-up questions. So, you keep it interactive. So if you want to learn from this paper, you ask some question, it gives you some follow-up question, you can follow back. So you can really have a nice discussion with the LLM on this paper. We're going to use Gemini, so we have initialized our Gemini client. Make sure your Gemini API is in the environment variable. We're going to use the 2.0 Flash model for this, and there's some other models here if you would like to use. We've got some utility function to write to file. Here is the download transcript open source tool that we are using, pretty handy. Pass on a YouTube video ID and gives you the transcript back in chunks. So you construct the entire transcript by appending or stitching the chunks together. You have then got some utility function to load the transcript. Here is the send message. Once you have initialized the client, which we will do in the next step, you pass on the client, and it basically calls the LLM, returns you the answer, and just logs how much our token usage was. All right. Here is the call to the LLM, our system prompt. Your expert tutor and analyst answer the question and provide two follow-up questions to continue the conversation. Answer strictly based on the provided content, keep the conversation exciting and engaging. So because this is a video tutorial style use case, we wanted to provide the answers strictly based on the provided content, not get too creative. Um, all right, so this is where we have created our context cache with Gemini, similar to the prompt caching example we looked earlier. In Gemini, it's a separate API call to create a cache. These caches are significantly cheaper than normal usage, up to 80% cheaper. Very, very useful for tools like this where the content is pretty deterministic and not changing rapidly, and you're just chatting to this context here. So you can save heaps of token and money on these. We have got our cache created. We have put an expiration of an hour on it, and this is where we have created our model. Okay, and let's have a look. So yeah, model has been initialized. This is the chat loop. Um, Pass it on a client and while true. So this is basically the interface that will just keep it multi-turn unless you're breaking the loop. And every time it answers. So again, thanks to structured results, you're getting your model back. You're providing the answer to the user, and you're also providing the follow-up to suggestions to the user as well. That is all for the tool. Let's see how it works. All right, asking for a link. Let's give it Carplotis link. Go for it. Okay, got the transcript, saved it, created a cache, model initialized. Okay, it should start asking us for questions very soon. So it is back. So it has yeah, given us a very short summary about the video tutorial. This is about understanding how transform architecture works, what the foundation model like, GPT involves building a character level, la la la. So let's ask, uh, what is a transformer? It's a neural network architecture introduced in the as part of the paper, core model of ChatGPT, da 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 da, and it gives us two suggestions and follow-up question. How does the self-attention work with the transformer? What are the key advantages of using a transform architecture? Nice. Okay, let me ask it something different. What are the top three concepts covered? Let's see. So top three concepts covered are understanding of transform architecture, implementing self-attention, and building a character level language model. And again, to follow up question, what is you can actually use this tool now. It's very usable. You can pick up any YouTube video you like, provide it, and you can ask questions to it, and it will keep it engaging, give you more follow-up questions. You can tune your prompt to make it more exciting, like it asks you some questions or whatever. It's amazing. Uh, Let's have a look at the transcript that it created. Pretty much what you would expect. Basically goes and pulls up the entire transcript, and this is what the LLM is using to answer our questions. Amazing. That's all for this part. Let's look at the other part of the assignments. Okay, so let's have a look at the second part of the assignment. How would we judge the quality of this AI? And if there's ever a better model in the market, how do we upgrade to it? Do we just blindly go for it, or do we make it more calculative or measured on which model should we upgrade? Should we even upgrade to the next one? It's a much deeper topic that hand-rolled models would not survive the test of time. You have to have very quantified way of measuring performance, and rolling out to a new model should be very systematic, not cowboy style. Just like you would upgrade your systems as you would roll out a traditional software engineering change. So, how do we do that? We do evaluations on the model quality, and then we try to see is the quality getting better or worse with introduction of a new model or a new feature or even a new prompt. When we're changing a prompt, did the AI quality get degraded? And you run evaluations to whenever you're trying to roll out something for your model. That is the only right way to ship AI features. Easier said than done. How do we actually do that in practice? We created a very nice utility that gives us question and lets us gives us answer based on our question. But how do we judge the quality? Is this project that we just created? What is the quality of the answer, or how do we measure the quality of this AI? So let's have a look. The first step to do that is if we want to do evaluations, we need to have a data set that we called the ground truth or the golden data set, which will basically be a exhaustive data set that tells us what a good answer should look like. Do we have an answer that we can then compare with LLM and see if our LLM was good at answering, was comparable, right? So what you would typically do is you will create a data set by hand. You will create a very rich data set by hand, and you would provide, hey, if this was the question, this is what the answer of it should look like. And you create a very exhaustive, rich, high quality data set, and then you call the LLM, and then you compare your handcrafted result with what LLM compared, and you try to see what the quality there is, and based on that aggregated stats you calculate quality of the AI model overall. This is a typical process. Let me take you through that process step by step. So in this part we are looking at a concept of building the ground truth. A ground truth is basically, like I said, a data set that tells us if this was a question, this is the right answer for it. Okay. Now, you would usually do that by hand. You would look at the transformers paper or you look at the DynamoDB paper and you'll create a rich data set by hand, and that is what you would use for computation. In this particular task, I'm going to show you an advanced technique where you use LLM for creating the ground truth as well. Again, it is LLM generated, so you might still want to have a human review on the generated data set, but what you can get out is you can get a big amount, a good sizable data set that you can use for model AI quality comparisons. Okay, so what have we done? We have created a ground truth creator model. Again, we are using our Gemini models for that. So we have got our Google GenAI client over here. We're using pydantic to provide the structure of what we want the results to be like. So an item would be a question and an answer, basically. And the overall data set would be a list of eval items. So basically a list of question and answers. If this was a question, what would the answer be? So ground truth answer based strictly on the transcript, okay? All right, let's have a look at what are we prompting the LLM for this. Act as an expert data annotator. Below is a transcript. Create a gold standard evaluation dataset consisting of number of questions and answer pairs. Requirements: question must be fact-based and answerable only using the transcript. Answers must be concise and accurate, and assign an incremental ID. And there you go, is the transcript. We are using Gemini 2.0 Flash for this. Flash is good at structured outputs, is why I picked up this particular model. And you are just passing the response type and the schema. Now, this is again similar to the last example we did for structured output, but this is using Gemini. Gemini now supports a list of schema that is pretty amazing. I did not see if the other models have also started doing that, but this is pretty cool. And that's it. You have made your call, you've passed your prompt, and here is the response. And once you have got that, you take it and write it to a file. And you can pass number of questions. Uh, this is a bit time consuming and just eats up a lot of tokens. So I have run it for you and I've got the response for you here. So this is what the script should produce. A long list of questions and what the expected answer would be. Now this is rich 100 uh, items in this list, and this is quite rich if you want to use this for your LLM output quality measurements. Similarly, this is one for the DynamoDB paper. So it was pretty easy to create this. You might just want to eyeball this data set just for quality, and there you go. You're good with a golden data set or a ground truth data set to compare or evaluate the quality of your model. Next step, we'll have a look how to use this to compare the quality of AI models. All right, let's have a look at how to evaluate AI quality via metrics. Now, we have, as part of the last assignment, we already created our ground truth. We know what a good answer would look like for a question that we have. This is this file here. We have created a very exhaustive list of questions and what the answer should be. As part of the actual assignment, we have created an AI application that we can ship to our user, and it lets the user chat with the video. They can provide a YouTube video ID and they can start chatting with the YouTube video. Amazing. So if you've got a product now, we have got a good data set on what good answers would look like. Now we need to connect these two and evaluate the quality of our product via these answers. So we have created the evaluation script over here. We're gonna use a lot of concept that we have learned or coded in the past few micro builds. We are gonna use pydantic for all of our strict objects, strict responses from the LLM. We are gonna use the LLM judge to understand or to assess if our product AI model responded compared to what our ground truth answer is. So what we're basically going to do, and this is a very standard way of measuring quality of AI across the industry. You send a question to your product, you get an answer, you send the expected answer that you already know to a LLM judge, and you provide the answer that your product provided to the LLM judge, and you're trying to compare how good or bad both of these answers are. So let's have a look at, and these are all the concepts that we have used in past exercises, so they should probably be familiar. Uh, so you are a strict evaluator. Here's a question, here's the expected answer, and here's the model answer. Score the model for and model answer for factual accuracy only. And here are the 5 levels of scoring we've got. And return a JSON with accuracy score. Here is our judge model. We have provided system prompt and the user prompt for it. And response format is the judge evaluation result, which we have defined here. So we are using our structured response along with our LLM judge over here, along with pydantic over here. Okay, compute overall metrics. This is a summarization because each item would give us some score. We have just written a function which just takes average of the individual scores and provides you a summarized score. This is something that you can create based on your domain. You might want to create a different scoring to just aggregate the overall score, or you might just want to, I don't know, look at the individual scores. Running evals. Let's look at the structure of this code. So you take a video ID, you run evals on that video ID, you provided the transcript path, you provided the evaluations path, or rather the ground truth path. So the transcript will probably be used for answering the question. The to initialize our LLM and ask it question. The ground truth is where we already know what the question and expected answers are, and then we limit how many evals do we want to run. And that's it. Response, it just logs a bunch of results, runs the evaluation, takes the eval results, and writes them to a file. Now, for this example, I have already run one set of this for a particular model, and I'll show you what the results look like, and then we'll run another one with a variation of the model so we can compare the results, a proper evaluation basically. So compare results of two different models and take a decision whether we should upgrade to the new model or not. So this was the first one that I did, where our production model was Gemini 2.0 Flashlight, and our judge evaluator was GPT-4 or Mini. And if you look at the structure, it has got a question: what does the layer specify? The expected answer, and what does the model respond, and what did the judge respond to it with a score of 5. You'll find something that is not so. Does the architecture exactly match the paper? Answer is no, but the model answered not exactly. So it just answered no, but in a different style, and the LLM judge says that no, this is not up to the quality. It was not and it's got a reasoning. It correctly identifies da da da, but does not exactly match the paper and provides a specific reason for deviation regarding. So it gave answer probably, but it not quite close. So the judge did not like it. Similar one over here. Uh, where do the key and value come from if the queries are produced from X, the whole separate external source? And the model again does mention external source, but the LLM judge did not quite like it because it adds additional information about so it gives some reasoning why it did not like it. So you see, it's using the ground truth answer with the actual model answer with the LLM judge to get a scoring as well as some reasoning. And we run it for a bunch of eval data sets from the ground truth. And then here is the summarization that we did. Total questions 10, pass rate was 1.0. The score distribution, we had 2 4 scores, 8 5 scores. Overall the accuracy came to 4.8. Pretty amazing actually. Now, let's have a look at if we had to upgrade our product to a new model that is available on market, how would we go around with it? We have already got a snapshot of model performance for our current product. We go to our product, we launch a variation of it. So let's say, where do we initialize the model? We had our flashlight model, right? Let's take a new model that is available in market now. So we're now using Gemini Flash, and let's look at other configs. So here we got cache. So we have a very high temperature, which means that it's a very creative model. So it will create facts if needed. So let's try to make it more deterministic just for the sake of this assignment. So we're using a new model, and we're also changing the model creativity. And now let's see if we, and then we just run the eval again as it is. It should be picking up the model from the code that we have already written, and it will try to compute another set of evals. Let's trigger it. It will probably take a while, and then we will come back to this assignment pretty soon. So it started evaluating. Um, Thanks to the cache, you can see it is massively saving money there, just trying to evaluate on the cached response. It has started this evaluation. It will take a bit of while. Let's come back to this once it's done. All right, so the evaluation is now complete, and you can see it has written new results there. And let's have a look at the new evaluation results. So this is now the new variation. This is the old one. This is the old one. This is the new one. The Flash model. 10 questions. You see that it has got a slightly better accuracy. Uh, Again, our data set is 10, but if you run it on the entire 100 evals data set, you will see a very clear difference there. So you observe that it has got a little better accuracy, and you can then again start having a look at the answers. You have got expected answer, model answers, and reasoning. You can keep this data set somewhere where you can come back to it and analyze it next time when there's a new model in market. But you're using a very calculated metric driven approach here, instead of just cowboy rolling out a new model because it was released and it's a better model. Not necessarily a better model might be degrading your product's performance because of the domain that you are in. So it's always important that you're able to assess the performance of the model objectively via metrics and then take a decision whether you're rolling out to a new model or not. That is all for this deep dive assignment. I hope it was useful. All right, friends, we made it. So this is the end of module one, prompt and context engineering. We did a bunch of micro builds every day, and then we used all of the concepts to create a project uh, that you can create and ship for your end users. As part of module one, we touched up on a bunch of concepts. LLM API vendors like Anthropic, OpenAI, Gemini. We looked at pydantic, which is a very powerful tool, structured results. We looked at advanced prompting and caching techniques. We looked at LLM judges. We looked at chat history and building multi-turn chat bots. We looked at ground truth data and how to use LLMs to create ground truth data rather than by hand. We looked at doing evals for objective model AI quality assessment and how to do A/B test when rolling out to new models. Um, Again, this course is not designed to teach you everything. We touched a lot of things, and hopefully, it gives you a starting point for you to be more curious and start exploring other concepts around what you've learned. Um, I hope it was useful. I hope you got some learning out of it, and I'm excited about module two. That's all for now. All the best. Take care. See you around. Bye.